Okay, hello guys. Today we are going to tackle this question matrix water injection. Okay, let's read the description. So given a two-dimensional matrix, the value of each grid represents the height of the terrain. The flow of the water will only flow up, down, right, and left, and it must flow from the high ground to the low ground, and the matrix is surrounded by water. Now it is filled with water from this particular coordinates, and we are asked to return if the water can flow out of the matrix. Okay, let's see an example. Here the input is a coordinate at 1, 1. So 1, 1 is here. So this is the height of the water, and we want to see if it can overflow to the boundary. So let's try the directions. So from the description, we know we can only go 4 directions, like up, down, right, and left. So start at 8. We see, can we go up? No, because this is low. 8 is lower than 18, so we cannot go up. And then we say, can we go to the right? And yes, we can, because this is a higher level than the 7. So then we output yes. And another example, we still start at here. The water level is 7. Then can we go not go from 7 to 9? Can we go to 8, 18, 11? No, we cannot go anywhere. We cannot go reach the boundaries, so the output is no. Okay. So I would say this is a typical search problem because we start from a source at this coordinate, and we want to see if we can reach to the boundaries. So there are generally two methods, BFS and breadth first search, and or DFS, depth first search. Let me demo the BFS first, which means we start from this source node. We want to go to all its neighbors. For example, here we want to go to the 4 directions, and then if we do not, and for its neighbor, if it is not, we did not reach the boundary, then we continue our search. Continuous search means it will still try to go to these 4 directions. And in this case, even it backtrace to 7. We don't need to record visited, because in our condition, this is 18 is higher than 7, so we will not reach. So we will not push the 7 into the quiz. So which means 18 is first discovered by 7, and then at the point of 18 we will not go back to 7 because the 7 is smaller. Okay, yeah, let's look at the code first. Okay, I have already written. Let's first do a boundary check. If the our matrix is now empty, then we simply return yes, which means we don't have any walls. And then let's let's declare directional matrix. This means we can go up, left, right, and down, so we can go to these 4 directions. And then this is the total number of the total row and the column total. And then since we are going to implement BFS, the breadth first search, I'm going to I declare a queue to temporarily store the position we are visiting. So first, we push into the where the source node, and then we want to end we push into the queue, and then we will go to all its neighbors. So here we already push the current node, source node, into the queue, and then we pull them out, and we get the current coordinates, and then we check if it is at the boundary. So here the boundary means the x coordinate is at 0 or at the row is either on the first row, the last row, or the column is the first column or last column. If it is yes, then we simply return the result. If not, we continue our search. So as we said, we can go 4 directions, and the current node, this is the current node coordinates. Then we can, the neighbor x and x y represents the 4 directions we can go to. And after we get the neighbors of the current position, and we want to check if the position is in the boundary. So this is checking the boundary of our neighbor position. So if it is in the boundary, and then we check if the height is smaller, because the water can only go from the higher level to the lower level. So if the neighbor level is lower, then we can flow. So by that, we push that neighbor coordinates into the queue. So, and then for the next loop, we will still check the neighbors of the source, and then the loop continues. So if we do not reach the yes, which means it is impossible, we do not find such node that is on the 4 boundaries, then we simply return no. So this is the BFS solution. Okay, let's submit it, and it will work. Okay, let me quickly show DFS. It is the same. Well, where's my submissions? Is this one? Yeah, okay. Sure, let me explain. Yeah, this is a DFS, which is from the source, then we pick one direction and go, and see if we can meet the boundaries. Okay, first check the edge cases, and we use a helper function to see if we can meet the direction. We can go to the boundary at this particular coordinates. If it is yes, then we return yes, or no, we return no. Okay, so the base case is we already find a node that is on the boundary, and or if it is not on the boundary, we will continue our search. So this is still the directional array, and we loop this. So this is the current coordinates, the row and the column, and then we add our directional. I'll add the 4 directions, so we can go 4 directions, and after we get the neighbor coordinates that where this node can go to, and we have to check if the neighbor water level is lower than the current lower level. That means the water can flow. Then we will continue the search, and we call this helper function again. And if it returns true, then with okay, and we return true. And finally, if we the code do not return true, which means we do not find such result, then we will simply return false. So yeah, let me know if you have any questions. Thank you.